What you are hearing now is a real recording of the wind on Venus. Captured by the Soviet Venera 13 probe back in 1982, this low, eerie rumble is the sound of a world that seems almost impossible to exist. A place where the ground is hot enough to melt metal, the air is thick enough to crush a human, and clouds rain acid. But here's the crazy part. Humans have been there. Well, not physically, but we've sent machines to land, survive, and even send back images and sounds from the surface of this hellish planet. So, why did we do it? Why did the Soviet Union spend decades obsessing over Venus, pouring time, money, and some of the most advanced technology of the time into missions that, for the most part, ended in failure? What made this planet so worth it? The 1960s and 70s were an intense time for space exploration. It was a brand new field, and figuring out how to build machines that could survive in harsh, unexplored places pushed engineering to its limits. Countries like the US and the USSR were in the middle of the space race, launching missions not only to show off their technological power, but also because there was a real fear that space could become the next battlefield. For the Soviet Union, one of the first major targets wasn't Mars or the Moon, it was Venus. Back then, astronomers barely knew anything about our sister planet because its thick, cloudy atmosphere hid everything from view. The Soviets kicked off their ambitious Venus program known as Venera, with the launch of Venera 1VA in February 1961. The start looked promising, but the rocket's second stage failed soon after liftoff, and the spacecraft never even made it into Earth's orbit. The USSR quickly swept the failure under the rug, acting as if it was part of the plan. Just 9 days later, they tried again. This time, they launched Venera 1, which successfully escaped Earth's orbit and set its course for Venus. However, a few months before the planned flyby, Venera 1 lost radio contact, preventing it from sending back any data. This set a pattern of challenges for the Venera program. Following this, the next two missions, part of the 2MV1 series, managed to reach Earth's orbit but couldn't break free due to engine issues, eventually falling back to Earth. The situation deteriorated further when the third stage of the rocket for Venera 2MV2, number 1, exploded during flight, destroying the spacecraft. The Soviets tried again, launching 2 more probes. Both missions also failed to leave Earth's orbit and crash back to the planet. By 1965, they were ready to try once more. This time, Venera 2 successfully reached Venus, but like its predecessors, communication issues doomed the mission. The spacecraft lost its data link before it could send back any information. Next was Venera 3. It made it all the way to the atmosphere before communications went silent. Even so, the spacecraft technically landed, or crash-landed, becoming the first human-made object to reach the surface of another planet. Not exactly a smooth victory, but a milestone nonetheless. Another Venera probe launched later that year failed spectacularly, crashing somewhere in Pennsylvania. By now, the program was running neck and neck with America's Mariner program, which was busy exploring Mars and doing Venus flybys. But in 1967, the Soviets finally caught a break. Venera 4 successfully entered Venus's atmosphere and transmitted data as it descended, making history as the first interplanetary broadcast. The celebration didn't last long. Just 5 days later, another probe failed to escape Earth's orbit and came crashing back down. In 1969, a few months before the United States landed on the Moon, 2 more Soviet probes managed to send back data from Venus's atmosphere before being crushed by the planet's extreme pressure. Finally, in 1970, after 14 attempts and 11 failures, a staggering success rate of just 21%, the Soviets achieved their goal. Venera 7 became the first spacecraft to land on Venus and successfully transmitted data from its surface. It managed to send signals for 23 minutes before being crushed and melted by the overwhelming heat and pressure, conditions that have been far worse than anyone expected. But once again, this victory was followed by another setback. Just 5 days after Venera 7's success, its sister probe failed to escape Earth's orbit and came crashing back down. The next real success wouldn't come until 1972, when Venera 8 made it to the surface of Venus and transmitted data for a solid 50 minutes before finally being melted and crushed by the planet's extreme conditions. To put this in perspective, by this time the United States was already routinely sending astronauts to the Moon. Not only had they landed humans on the lunar surface multiple times, but they'd even brought 2 cars, the lunar roving vehicles, for astronauts to drive around. A third rover would follow with the final Apollo mission just a few months later. Meanwhile, the Soviets faced yet another setback when their next probe exploded while trying to enter its injection orbit. Between 1975 and 1983, the Soviets began refining their Venus missions. After years of failures, they were starting to figure out how to survive, if only briefly, on the surface of this unforgiving world. The missions during this period weren't just about landing, they were also about doing science. The Soviets were determined to get images, soil samples, and atmospheric data that would give humanity a deeper understanding of Venus. Some of these landers were equipped with instruments to analyze the planet's chemical makeup, and even color cameras to capture what the surface truly looked like. But even with improved designs, Venus still fought back. A recurring problem plagued many of these missions. The lens cap on the cameras failed to pop off. In one particularly frustrating case, the lens cap landed directly under the instrument meant to measure soil compressibility, meaning the spacecraft ended up analyzing its own cap instead of the Venusian soil. Despite these setbacks, the images that did make it back to Earth were groundbreaking. They showed a barren alien world strewn with sharp angular rocks and covered in a faint orange haze caused by the thick, toxic atmosphere. Venus's surface looked like a lifeless wasteland, a world scorched and crushed beyond recognition. These were the first color images of another planet, and even though they were grainy and limited, they painted a chilling picture of what happens when a planet's atmosphere spirals out of control. The data collected during this period also confirmed that Venus's surface was largely made of volcanic basalt, a clear sign of past volcanic activity. Scientists began to realize that Venus wasn't just dead, it had once been alive, geologically speaking, and perhaps more active than they'd imagined. The most advanced Venus missions launched in the early 1980s were Venera 13 and Venera 14, and these marked the pinnacle of Soviet exploration. Venera 13 landed on March 1, 1982, and survived an incredible 127 minutes on the surface, more than 2 hours of transmitting data in conditions that could melt lead. It sent back stunning panoramic images of the Venusian terrain, showing jagged rocks and a sky that glowed with an eerie orange hue. The lander even recorded the sounds of Venus for the first time, low, haunting rumbles of wind sweeping across the barren surface. Venera 14 followed just days later and lasted nearly an hour, sending back similar images and data. Both missions analyzed the chemical composition of Venus's surface, confirming that the rocks were volcanic and rich in potassium, thorium, and uranium, elements typically found in basaltic rock. These findings suggest that Venus had experienced massive volcanic eruptions in the past, events that may have reshaped the entire planet. The Soviet Venus program didn't stop there. In 1984, the Soviets launched Vega 1 and Vega 2, a pair of probes with a new twist. They carried balloons designed to float in Venus's upper atmosphere. Unlike the surface, which is a blazing inferno, the upper atmosphere of Venus is relatively mild, with Earth-like temperatures and pressures about 50 kilometers above the ground. The balloons floated for days, drifting on Venus's powerful winds and sending back valuable data about the planet's atmosphere. This was a remarkable achievement. For a brief time, the Soviet Union was not just surviving on Venus, they were exploring its skies. But as the 1980s came to an end, so did the Soviet Union's obsession with Venus. The collapse of the USSR meant the end of funding for ambitious space missions, and Venus, once a symbol of Soviet determination, was left behind. For decades, no major missions returned to Earth's fiery twin, and Venus faded into the background as Mars became the new focus of exploration. However, the discoveries made during the Venera and Vega missions laid the foundation for everything we know about Venus today. They revealed a world of extreme heat, crushing pressure, and volcanic plains, a planet that might have once been like Earth before it turned into a cautionary tale of what happens when a greenhouse effect spirals out of control. More recently, Venus has returned to the spotlight thanks to a surprising discovery in its atmosphere. In 2020, scientists announced the detection of phosphine gas high above the planet's surface. On Earth, phosphine is a byproduct of biological processes produced by microbes that live in oxygen-free environments. This raised an exciting question: could something be alive in the clouds of Venus? While it's unlikely that phosphine alone proves the existence of life, it's enough to make scientists take a second look at this planet. If the phosphine isn't coming from life, then it must have been created by some unknown chemical or geological process, something we haven't seen anywhere else in the solar system. Either way, it's a mystery worth solving, and it's pushed Venus back into the center of planetary exploration. NASA has announced two significant missions, Da Vinci and Veritas. The Da Vinci mission, which stands for Deep Atmosphere Venus Investigation of Noble Gases, Chemistry and Imaging, is scheduled to launch in the early 2030s. The mission will send both an orbiter and a descent probe to Venus. The descent probe will travel through Venus's atmosphere, sampling and returning measurements down to the surface. These measurements are crucial for understanding the origin and evolution of Venus's atmosphere and how it differs from those of Earth and Mars. Before reaching the surface, the probe will capture high-resolution images of the planet's rigid terrain, known as tesserae. These tesserae are areas of interest because they are believed to be among the oldest geological features on Venus, potentially offering clues about the planet's geological history and whether it might have had plate tectonics in the past. The Veritas mission, which stands for Venus Emissivity, Radioscience, INSAR Topography and Spectroscopy, is planned to orbit Venus and return data for approximately 2.5 Earth years. Its scientific objectives include studying past and present water, current or recent volcanic activity, and the geologic evolution of Venus. Veritas will have a low circular orbit around Venus, allowing its instruments to collect high-resolution global maps of the surface hidden beneath the clouds. The European Space Agency, ESA, is also contributing with its ENVISION mission, set to launch in the early 2030s. ENVISION aims to study Venus's surface and subsurface, analyzing its geological activity and understanding the planet's evolution. This mission will complement NASA's efforts, providing a more comprehensive understanding of Venus. Private companies are joining the endeavor as well. For instance, Rocket Lab has announced plans to launch a small probe to Venus, potentially as early as 2025. This mission aims to study the planet's atmosphere and search for signs of life, focusing on the cloud layers where conditions might be more temperate. These upcoming missions signify a renewed commitment to exploring Venus. The data collected will be instrumental in understanding why Venus, despite its similarities to Earth, evolved into such a hostile environment. Insights gained could also inform our understanding of Earth's climate and the potential habitability of exoplanets with similar characteristics. The notion of human habitation on Venus has long been dismissed due to its extreme surface conditions, temperatures around 465 degrees Celsius or 869 degrees Fahrenheit, pressures 92 times that of Earth's at sea level, and clouds of sulfuric acid. However, recent discussions have entertained the possibility of human presence in Venus's upper atmosphere. Approximately 50 kilometers, about 31 miles above Venus's surface, the atmospheric pressure and temperature are much more Earth-like. This region, often referred to as the habitable zone of Venus's atmosphere, presents an intriguing opportunity for potential human exploration or even colonization. Concepts such as floating habitats or aerostats have been proposed, where structures could remain buoyant in the dense atmosphere, providing a platform for scientific research and exploration. Terraforming Venus, altering its environment to make it more Earth-like, remains a speculative and monumental challenge. Proposals have included methods to reduce the dense carbon dioxide atmosphere, such as introducing photosynthetic organisms or deploying large-scale solar reflectors to cool the planet. However, these ideas are currently beyond our technological capabilities and would require unprecedented resources and timeframes. For now, the focus remains on robotic exploration to gather more data about Venus's atmosphere, geology, and potential for past habitability. The upcoming missions will provide critical insights that could inform any future endeavors related to human exploration or habitation. Despite everything we've learned, Venus is still one of the most mysterious planets in our solar system. Most of the surface data we have comes from old Soviet missions and radar scans, yet we've only scratched the surface, literally. Beneath the thick clouds and volcanic plains, Venus may still hold answers about its past, its interior, and processes we've never seen elsewhere. There are plenty of clues, but no clear answers, and that's what makes Venus so fascinating. For one, Venus may not be as dead as we think. While its volcanic plains appear ancient, some evidence suggests that Venus is still geologically active. Recent radar mapping shows bright spots on the surface that could be newly solidified lava flows, hinting at ongoing volcanic eruptions. Scientists believe Venus may have massive volcanic resets, where heat builds up under its crust and then erupts in planet-wide events. This kind of global resurfacing might have happened hundreds of millions of years ago, or it might still be happening today. If we could confirm recent volcanic activity, it would change everything. Active volcanoes could explain some of the strange chemicals in Venus's atmosphere, like sulfur compounds which are constantly being replenished. Understanding how Venus releases internal heat would also help us compare its geology to Earth's and figure out how similar planets behave under extreme pressure. Beneath the surface, Venus's interior structure is another mystery. Earth has a core, mantle, and crust that are constantly in motion due to plate tectonics. But Venus seems different. Its lack of plate tectonics has baffled scientists for decades. How does heat escape from Venus's interior if there are no moving plates? One theory is that Venus's crust is too thick and strong to break apart into plates, forcing heat to build up until it bursts through in massive volcanic events. Another theory suggests Venus might have a stagnant lid, a solid crust with no movement, but occasional rips or cracks where magma pushes through. Modern missions like NASA's upcoming Veritas are designed to investigate these questions using radar to probe Venus's surface and gravity data to study its interior structure. If we can figure out what's happening beneath Venus's surface, it will give us a better understanding of how rocky planets, including Earth, evolve over time. Beyond its geology, Venus may also have a complex atmosphere that we don't fully understand. While we've talked about the phosphine discovery, it's just one part of the puzzle. Venus's atmosphere is dynamic and constantly changing, with bizarre phenomena we don't see on Earth. For example, super-rotating winds in Venus's upper atmosphere move at speeds over 250 miles per hour, circling the entire planet in just a few days. Scientists don't know why Venus's atmosphere behaves this way, and understanding it could give us insights into weather systems on other planets. There's also the mystery of Venus's polar vortices, giant swirling storms at the planet's poles that behave in strange, unpredictable ways. These storms are like hurricanes, but far more stable, existing for years at a time. Recent observations from Japan's Akatsuki probe revealed that these vortices are shaped by temperature differences and complex wind patterns, But we still don't fully understand their structure or origins. Studying Venus's atmosphere, including these storms, helps us model extreme weather systems and better understand planetary atmospheres, including our own. Another bizarre feature of Venus is its lack of a magnetic field. Earth's magnetic field protects us from solar radiation and plays a key role in maintaining our atmosphere. Venus, despite being similar in size and composition to Earth, has no detectable magnetic field. This has caused its atmosphere to be stripped away by solar winds over billions of years, leaving Venus exposed and vulnerable. But why doesn't Venus have a magnetic field? One possibility is that Venus's core, which should be molten like Earth's, isn't moving the way Earth's does. Without a molten convecting core, Venus can't generate a magnetic field, and that might have been one of the key factors that doomed it. Studying Venus's core and its lack of magnetism could help scientists understand why some planets develop protective fields while others don't, a question that's crucial as we study potential habitable exoplanets in other solar systems. Finally, Venus presents one of the biggest mysteries of all. Was it once habitable? Venus might have had oceans billions of years ago, but there's growing evidence that Venus stayed habitable for much longer than previously thought. Recent climate models suggest that Venus may have had liquid water for up to 2 billion years, plenty of time for life to evolve. If true, this would mean Venus was potentially the first habitable planet in the solar system, long before Earth became the thriving world we know today. At some point, something changed. Venus's oceans evaporated and the atmosphere became dominated by carbon dioxide, triggering the runaway greenhouse effect that turned it into the hellish world we see today. But what caused this shift? Was it a massive volcanic event? Did the sun's increasing brightness slowly boil away Venus's water? Or was it something else entirely? These mysteries make Venus more than just a cautionary tale. It's a world of untapped scientific potential. Every unanswered question about Venus brings us closer to understanding how planets form, evolve, and in some cases die. It's a reminder that even the most extreme environments can hold valuable lessons. Venus forces us to think differently about life, habitability, and the delicate balance that makes Earth so unique. With modern technology and new missions on the horizon, we're finally ready to return to Venus and uncover the answers that have eluded us for so long. Venus matters because it challenges us to solve some of the biggest puzzles in planetary science. It offers a glimpse into what could happen if we lose control of Earth's climate. It may even help us find clues to life in the most unexpected places. For all its heat, pressure, and hostility, Venus remains one of the most important and most fascinating worlds in our solar system. Venus is a planet that both challenges and fascinates us. For decades, it was dismissed as a dead, hostile world, a place too dangerous and extreme for meaningful exploration. But as we've seen, Venus holds far more than just scorching heat and crushing pressure. It's a planet with stories written across its volcanic plains, mysteries swirling in its toxic clouds, and secrets buried deep beneath its crust. It's a reminder of how little we truly know about the solar system's rocky worlds and how much we still have to learn. The Soviet Union's Venera missions in the 20th century opened the door to Venus, proving that exploration, even in the most impossible places, is possible with enough persistence and ingenuity. Those early landers, despite their short lifespans, gave us our first glimpses of the surface, a desolate volcanic wasteland beneath thick clouds of carbon dioxide. From those efforts, we learned how planets can evolve into such extreme states, and how similar Venus once was to Earth before their paths diverged. Now, with modern missions on the horizon, humanity is returning to Venus with fresh eyes and better tools. NASA's Da Vinci and Veritas missions, along with the European Space Agency's Envision, will reveal Venus in ways we've never seen before, from mapping its hidden surface to sampling its atmosphere. These missions will help us answer questions about Venus's history, its volcanic activity, and its potential for life. If Venus once had oceans and a temperate climate, we need to understand what went wrong. Did Venus ever have life? Could something still survive in its clouds today? And most importantly, what does Venus teach us about Earth's own fragile atmosphere? Venus matters because it pushes us to explore the unknown. Its mysteries are vast and its lessons are urgent. By studying Venus, we gain not only insights into the workings of other planets, but also a deeper understanding of Earth's past, present, and future. The cautionary tale of Venus's runaway greenhouse effect serves as a stark reminder of what can happen when a planet's atmosphere spirals out of control. At the same time, Venus's similarities to Earth gives us hope that we might someday explore its clouds, blue floating habitats, or even find signs of life in the most unexpected places. In the end, Venus is more than just a hot, hellish world. It's a symbol of human curiosity and determination. It represents the drive to push boundaries, to explore the impossible, and to seek answers in places no one thought we could reach. With new missions ready to unlock its secrets, Venus is poised to teach us more than we ever imagined. Whether it's the past life of a habitable world, the active forces shaping its surface, or the limits of life itself, Venus is a story that's far from over. And perhaps, as we learn more about this fiery, mysterious twin of Earth, we'll discover not just what happened to Venus, but what it means for us, here on our fragile blue planet.